All right, so the problem I gave you yesterday, okay, said that Forrest has a sample of hydrogen gas in a Ziploc bag. And the volume is 20.25 liters. The pressure is 1.05 atmospheres, and the temperature is 25.0 degrees C. And it asks what amount of gas does he have. All right, maybe it'll straighten out here in a minute. So we've got a volume of 0.25 liters. We've got a pressure of 1.05 atmospheres. Let's see, we've got a temperature of 25.0 degrees C. And it asks what amount of gas does he have. Well, N is the symbol we use for the amount of gas, and it's always measured in moles. Moles is the SI unit, this International System of Units, unit for measuring the amount of a substance. So this is how we're going to measure the amount of a substance. All right. So let's say temperature. We can't use temperature in degrees C. Okay, we have to take this 25 degrees C. We have to add 273.15 to it to get the Kelvin temperature. Gas laws can never be solved in degrees C. Okay? So that's 1.5 here. 298.15. We have a digit over here that's added to some empty slot. So that means we have to round off that last digit. And we draw an arrow to show a rounding off. And we round it off to 298.2 K. And that's the temperature we're going to use. Okay? 298.2 K. So let's say we've got V, and we've got P and T and N. Let's look on our list of gas laws and see if we can find one that comes close to matching those units of measurement, or those dimensions of measurement. Okay. So on your test references, all your gas laws are right up here in the upper left-hand corner. Okay. And this one right here has pressure. Okay. Has volume. It has temperature. It has N. The only thing that we don't have that's in this is R. But the R you always have. Everybody always has R. And R is the ideal gas constant. And that's on the front page of your test references. Okay? All we have to do is match the version of R we need for these variables. So let's see if we can do that. I've got atmospheres here, and this is the only version of R that has atmospheres in it. So that is the only R we can use for this calculation. Okay? All right, so we want to take and write out our R that we're going to use. 0.08206 liters times atmospheres over Kelvin times moles. All right, now, you need to remember, I've said it before, I'm going to say it again, and I know somebody's going to probably make the mistake on the test anyway, but these are not variables. You don't plug numbers in where it has the letter L for the liters. You don't take 0.25 liters and plug it in right there. These are variables. I mean, these are measurement units, not variables. The variables are in the law. PV equals nRT. All of these are variables except for R, which is a constant. And so what you're going to do is plug in V into this equation, and P into this equation, and T into this equation, and R, actually this should be R, but I don't want to put it in for N. N is what we're trying to find. Okay? So you're going to plug these values into this equation, not into this constant. All right, so let's start with P. So we got 1.05 atmospheres. We're going to multiply it times the volume, which is 0.25 liters. Okay, we're trying to find N. We don't know that yet. Going to multiply that times R, 0.08206 liters times atmospheres over Kelvin times moles. And let's see, the last part is the T, so that's 298.2 K. Alright, the reason I put this over 1 is because the way we get N all by itself is to multiply both sides of the equation by those things that will get rid of these values on this side and move them over on this side. Okay? So we want to put this on the bottom of a fraction and this on the top of a fraction. So they'll cancel out. Well, that just means we're multiplying by the reciprocal. Kelvin times moles over 0.08206 liters times atmospheres. Okay? That's going to allow us to cancel all that. But I need to also put this on the bottom of a fraction to cancel that out. 1 over 298.2 K. Now, the rule is, whatever we do to this side of the equation, we have to do the other side of the equation. So if I multiplied these things on this side of the equation, I've got to take those same things and put them over here. I have to. Okay, and that's why we need to turn that paper sideways, because you see how much space we're going to need? And you can't write big. If you're a big writer, learn to write a little smaller. Okay? Now, here's why we're doing it that way. This is the point. Okay, Robbie, I know you're having fun, but let's pay attention right here. This is critical. Okay? This number is exactly the same as this number, and you've got this number on the top and this one on the bottom. They can cancel them out. Liters on the top and bottom can cancel out. Atmospheres on the top and bottom can cancel out. 298.2, that's the same number there and there. Those can cancel out. K can cancel out because it's exactly the same.
Doesn't all of it cancel each other out?
Pretty much. K here is going to cancel. Yeah. And moles are going to cancel. Okay. Huh? You have to show your work. All right. Let's look at the other side of the equation. Just look at this fraction right here. Just 1.05 atmospheres, or that number. If I put it in a fraction over 1, does it change the amount? No. It's exactly the same thing. We're going to put it there so we can see how to do the cancellation. And what about this one? If I put this over, doesn't change the amount if I put it over 1. So I'm putting them over 1 because then I can clearly see that atmospheres that are here on the bottom, here and here, they can cancel each other out. And liters, which are here on the top and here on the bottom, can cancel out. Just the liters, not the number. There's no number to cancel here, just those units of measurement. Now Kelvin over here, that cancels. Okay? So what I have left, and the only units of measurement I have left, is MOL. Well, moles is the SI unit that measures the amount of a substance. And that's what N is. We're looking for the amount of gas. That's what the problem asks for. So now all we have to do is solve this part of the problem.
So the problem for the same thing are equal to moles.
The units of measurement to the left should match the variable we have left on the other side of the equal sign.
Okay.
And if we've done that, we know we've set it up right, and all that's left to do now is the math part. Does that make sense? Does that answer your question?
I kind of got me confused when you say it should match the other part of the equation.
Okay. Moles is the unit of measurement that measures N. N is the amount of substance. Moles measures the amount of substance. So if the unit of measurement matches the variable, then we're set up right. So we're ready to do the math now, so you need your calculator. Okay, so I've got 1.05. And multiply it times 0.25 because both those are on the top of the fractions. I'm going to hit enter.
Put that one once upon.
Oh, yeah, I did, didn't I? How about that? Do it again. 1.05 times 0.25. Whoop. Okay. Now we're going to divide by this number as a separate operation. So once I've got an answer, once I've hit enter or equals on my calculator, James and Skylar, and Dick, let's pay attention here. Okay. Then I can divide this. So I'm gonna hit, now that I've got that answer, I'm going to divide by 298.2. Hit enter. Then I'm going to divide by this. Divided by 0.08206. Hit enter. And that's the answer I'm looking for, at least initially, because I still have to round off. So 0.0107272933. The units we have left here, moles, and that equals N. Okay? Yes? It doesn't matter which one of these you divide by first. I usually take them in orders all. Okay? All right, now we have to look and round off.
So you divide and then you divide again?
Yes.
Multiply, divide, divide.
Now, some calculators will do it without having to do it twice. You can just put them in as two divides, but the problem is that not all calculators have that syntax. But this way always works for all calculators. Okay?
Is it always going to be like where you multiply 105 times 0.25? It should always be in that format?
Well, you have to look at the way the fractions are set up. You multiply everything across the top first, and then hit enter, and divide by something on the bottom, hit enter. If there's something else at the bottom, you divide, hit enter, and all that. Okay? All right. So now let's look at our significant digits. This number has 3 significant digits. This measurement has 2. This measurement has 2, and this calculated number has 4. And we need to use all the measured, 1, 2, 3 measured numbers, and the calculated numbers, 1 calculated number. You look at all of those and determine the one that has the least digits, and that's this number right here, which only has 2 digits. So our final answer needs to have 2. You need to remember that leading zeros are never significant. So our first significant digit is this 1 here. That makes this number significant because I need 2 of them, and everything after that is insignificant, so we underline it to show that. Then we're going to draw an arrow to show that the next number we're writing is rounded off. They're not equal. You have to show an arrow to show rounding. So then our answer is going to be 0.01, and that 0 is rounded up because of this 7 here. So 1 moles equals N. There's our answer. Okay? Does that make sense to everybody?
Yeah, now it does.
All right, now I'm going to give you, you can solve it this way every day, all the time. But I'm going to give you one other way to solve it that might be shorter for some of you, and you're allowed to use it. That work for you? Huh? I don't think so, but if it is, just ignore me. Okay? Let's write out this equation here. PV equals, and what we're looking for here, I've already figured out what I'm looking for is N. Okay? I'm going to just color code it here for a second. Instead of putting in all our values up here, instead of plugging in the known values up here and then solving in this way, I can get N by itself first. Okay? And I do that by dividing both sides of this equation by RT. Okay?
So we can just put that and then just do it.
Hold on. Then RT cancels on this side. I got N by itself. Alright? If I do that, then I'm also going to flip it around and put N on the left. Is that okay with everybody?
Yeah.
Alright, so I'm going to say N equals PV over RT. Got that?
Yeah.
All right, so let's plug in these values then. In
Oh, this is much easier.
P, well maybe not. Just wait till I finish. All right, so our pressure is 1.05 atmospheres. Okay, the volume here is 0.25 liters. On the bottom we've got R, 0.08206 liters times atmospheres over Kelvin times moles. We're going to multiply that by the temperature here, which is 298.2 K. Okay? But what I have here is what's called a complex fraction.
Yeah. Hold on. This way.
So if you ask your math teacher about complex fractions, he or she will tell you how to solve that.
Okay.
And the way that you solve it is, at least the term that I was always taught to use, is invert and multiply. Sometimes math teachers will use the term multiply by the reciprocal. All right? So here's what we're going to do. We're going to set this up so everything on the top is in a fraction. I'm putting these over 1, just like I put these over 1. Okay? I put the temperature over 1 because that's the way it is here. What we're going to do then is rewrite the equation by writing out the things that are on the top. I'm sorry, I need an equal sign here. 1.05 atmospheres times 0.25 liters, and put those over 1. Then I'm going to invert this. So I'm going to flip it and multiply it. So I'm going to put it up here, and I'm going to say Kelvin times moles over 0.08206 liters times atmospheres. I got to flip this one too. Times 1 over 298.2 K. Now, if this part, the flipping and multiplying, this invert and multiply, are both on the reciprocal, it's hard for you to do, and you prefer to do this, do that. Use the method that works for you. Okay? Yes?
When you first began with the N equals PV, I thought since you already knew that, since you already know that's going to cancel out each other, I mean, depending on the equation that you give us, since you already know it's going to cancel out each other, it'll just be better off if we just had the N equals the top and the bottom. That's what I thought you was going to do.
No. Because I want you to make sure that you've got all your units of measurement right. So here we have the ATMs canceling, liters cancel, Kelvin cancels, and I'm left with moles, and I'm looking for moles because I'm looking for the amount of substance. So we're going to plug this in there, and we're going to get the same answer.
Yeah, this.
It's less work, actually. More about the same.
It just got to be lost, I think, on the reciprocal part.
Well, it's up to you. I find this to be less work than this, but it's your call. You decide how you want to do it. Okay? Huh? So you can set up your equation to isolate your unknown first. The procedure I've taught you for solving these is to plug in your known values and then isolate the unknown. It is fine, however, if you isolate the unknown first and then plug in your knowns. Does that make sense? So those two steps can be reversed. Other steps cannot be changed around, but those two steps can be. Okay? So up here, this is method 1. And down here is method 2. If you want to call them that. Any questions?